Today we're learning to solve simultaneous equations graphically, and what I've got here is an everyday situation where you're going to try and hire a car. You may hire it for 1 day and we want to know the cost. We want to know the cost for 3 days. We want to know the cost for a 1 week hire. And what we're trying to do is we're trying to choose between these two companies which company we're going to go for. So what I'm going to do first of all is I'm going to draw a graph of the information I've got in front of me, and that will help me choose which company I'm going to go for. After this, we've got a couple of just working out where straight lines cross over as a start to the topic, and that will be the work that you'll have for today. So let's have a look at this one here. So two hire companies advertise as shown, okay? Right, so which company will we choose for these day hires that we're after? So first thing I'm going to look at is I'm going to look at hire a car. And I know that they've got a £40 deposit, and every day I'm with them, then that's going to be £10. So for every day it's £10, and then I'm going to add on £40 because that's what I'll pay as a deposit. So the cost for hire a car is the cost is going to be equal to £10 every day, so £10 times days. Is that okay if I call that D? And what we'll do is we'll add on the deposit that we started with, which was £40. So there's an equation, a linear equation for hire a car, and that's how I'm going to be working out the equation of that line and drawing it on a graph. So I'm also going to graph on the same plot rent a car or car rent company. And what I'm going to be doing with this one here is I'm going to be looking at the same type of information. So the cost for this car company is going to be £20 every day. So £20 every day. So I'm trying to think of that as a kind of gradient. So 20 times the days. And what I've got is I've got a £10 deposit. So I'm going to add £10 onto that as well. So there's the two linear equations that I'm just going to sketch on the same graph. Okay. Right, so the first one that we're going to draw is C is equal to 10D plus 40. Now, I've already been through various methods of drawing straight lines. I'm just going to do them reasonably quickly. You choose the method that suits you best, and you go ahead and do that, okay? So I'm going to try and do this quickly to keep the video reasonably short. So for simultaneous equations, what we're going to do is sketch these two graphs. Right, first one that I'm going to do is going to be C is equal to 10D plus 40. So that starts at 40 because that's my y-intercept, okay? Or it's my c-axis in this case. And I'm going to go up 10 as my gradient. So every time I go along 1, so you've got to look at the scales, along 1 I go up 10, along 1 up 10, along 1 up 10, along 1 up 10. And that would just continue going for however many days I would want to hire that car. So what I'll do is I'm going to draw a line through this graph, and that will give me the hire a car's costs as we go through its hire process. Okay, so this line here is C equals 10D, 10 days plus 40 for my deposit. Okay, so that's that one. Next one that I'm going to look at is the company up above. That's car rent company. So C is equal to 20D plus 10. So I'm going to start at 10. And what we'll do is we'll move up a gradient of 20. So every time I go along 1, I'll go up 20. So let's draw that as well. So I'm going to start at 10. So down the bottom here, starting at 10. And what we're doing is we're going along 1 and up 20. 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 20. So there's a line I'm going to draw for this car company. So here we go. So I'll just draw that up there. So this one here is going to be C is equal to, and that's going to be 20D plus 10, okay, plus 10. There we go. So there's the two equations that I've drawn for both companies. So let's look and see what we're trying to work out. So first thing we're trying to work out is a 1 day hire. We'll then go into 3 days, and then we'll go into 1 week hire, and we'll see which one's best here, okay? So two different companies. So if I just look up from 1 day, so this is a 1 day hire here. So if I think about coming up on this line here, I can see that I'm going to be hitting each of these lines at a different place. So for the purple line that I've got here, that was car rent company. They're going to charge me £30 because that coordinate there is 130. So that's going to be £30 they're going to charge me. For the green line that's there, it's going to be hire a car. So for hire a car, they're going to charge me, if I look across on this axis, that would be £50 they're going to charge me. So for a 1 day hire, I'm going to choose this company here, which is Car Rent Company. Okay, so for a 1 day hire, it's going to be Car Rent Company. And the reason for that is since £30 is less than £50. Okay, right, so my next question was for a 3 day hire. So if I look at it for 3 days. Now 3 days comes up from here, and strange thing is, what we do is both the lines intersect at that point. So that's a point of intersection of the lines, which is key when we're working out simultaneous equations. And that's really what we're trying to do when we solve simultaneous equations. It's find the point where they cross over. So that point there is 3 along the way, so 3 days along, £70 up the way, so £70. So both companies are going to charge me £70 for the hire. So I guess if I had to make a decision on which one I was going to choose, I'd probably see which cars they actually hire and which one I'd prefer to drive, and that would cost me £70. So that would be any, I would say, any of the two, both at £70 each, okay, for the 3 day hire. So it doesn't matter which one I really choose. The last one is the 1 week hire. So if I look for a 1 week hire, so let's see what we've got. So 1 week, 7 days. So I'm going to go up here. So if I go up in that direction there, what that's going to tell me is I've got a point there, which is going to be the point 7, and that is going to be 110. And the point up here, where it crosses over, is 7 and 150. So I can see here that one of the companies is going to charge me 110. One of the companies, is going to charge me 150. So I think I'm going to go with this company here, which is the green one. That green company is going to be hire a car. So for 1 week hire, it's going to be hire a car. And for hire a car, they're going to charge me 110. So it'll be 110 is less than the 150, and that would be my reason that I'm choosing for going with that company. So when we're solving simultaneous equations graphically, all we're doing is we're referring back to the straight line topic that we've worked on. And remember, I'll have a card up above on the video that will show you a link to how to sketch straight lines. The key point here for simultaneous equations usually is that point there, and it's where they intersect. So the solution, if I was trying to solve simultaneous equations graphically for these two equations, would be x is equal to 3, y is equal to 70, if that was going to be an x and y graph. But this one here is time in days, so I called that a d, and up at the top was c. So it'd be 3 for d, and for c for the cost would be 70. So that's what we're going to be trying to work out with simultaneous equation solving. So let's look at a kind of simpler version of what we're looking at now. So what we're going to be trying to do is just looking at a couple of straight lines. And what we want to know is the coordinates of where the points or where these lines cross over. Okay, so where the lines cross over, and what we usually call that is the point of intersection of the lines, or a POI. Usually I call it POI once I get to that point. So what I'm going to do here is I'm going to draw both lines and I'm going to see where they cross over. The method I'm going to use for the first one, so the first one I've got is y is equal to 2x minus 4. I'm going to draw that line, okay? So I'm going to say when x equals 0, why don't we go with that? When x equals 0, y equals 2 times 0 minus 4, so that gives me a minus 4. So that first coordinate I've got is x is 0 and y is minus 4. So 0 minus 4, so that's down there, okay, on my graph. When x is equal to 1, I know that y is equal to 2 times 1 minus 4, so that gives me minus 2. So the coordinate I've got there is x is 1 and y is minus 2, and I'll plot that in a minute. When x is equal to 2, y is equal to 2 times 2 minus 4. So all I'm doing is just using the equation again, remember, and that equals 0. So that was 2, 0 that I'm going to be working out from there. So what I'll do is I'll go and plot these 3 points, and that'll allow me to draw the line. So first point was 0 minus 4, or 0 negative 4. So that's it down there, okay? There's the first point. I've got, let's see, 1 and minus 2. 1 and minus 2. It's there. And 2 and 0, so 2 along and 0 up or down is there. And what I'll do is I'll just draw a line right through that point that's there. So if I go for that, let's see, there we go, and there's the line y is equal to 2x minus 4. Okay, so I'm going to do the same with the other line, and what I want to do is I want to find out where the two lines cross over. So the other line is y is equal to negative x plus 5, okay? So for this one here, I'm just going to do it the old way, and I'm going to start with my c value. My c value is 5, and my gradient is equal to minus 1. So remember, it's the m value that's sitting in front of x. So I'm going to start at 5. So if I go for 5, I'll go for here. So I'm going to go up here, starting at 5. And what I'm going to do is I'm going to do, so my gradient of negative 1 is just the same as if I go along one place, I go down by one place, okay? So let's look at the scales. The scales are okay for us. So I'll go along 1 and down 1. So that's there. Along 1 and down 1. From there, along 1 and down 1. Along 1 and down 1. And I've already seen where the line's going to cross over. So what I'll do is I'll join my lines up from there through there. Okay, so my point of intersection is this point here. Okay, so POI is 3 along the way, okay, that's for my x coordinate, and it's going to be 2 up for my y coordinate. So there's the point of intersection, and that's all I'm trying to do with this work. I'm just trying to find out where these lines cross over. Okay, let's try another one. Okay, so example 2. What we're trying to do here is we're trying to find the coordinates of the point of intersection of these two lines that are here. Right, so I'm going to start with this equation here. So I've got 5x plus 2y is equal to 20. What I'm going to do is I'm going to do it a different way. So I'm going to let x equal 0. If I let x equal 0, so that will be 5 times 0 plus 2y equals 20. That there becomes 0, so that leaves me with 2y is equal to 20. And if I divide both sides by 2, y is then equal to 10. So what that does is it gives me the point x is 0, y is 10. So that's going to be a 0, 10 point that I'm going to be plotting on the graph. The other point that I want to find out is when I let y equal 0. Okay, so if I let y equal 0, so I've got 5x plus 2 times, and remember all I'm doing is substituting into there a 0 for y. So that becomes 0, that disappears, so I've got 5x is equal to 20, and if I divide both sides by 5, I've got x is equal to 4. So what that gives me is an x coordinate of 4, right, and a y coordinate of 0. So that gives me 2 points to plot on this graph. So I'll go ahead and do that right away. So 0, 10, 0 along the way and 10 up would take me to there. 4 along and 0 up or down takes me to there. And all I'm going to do is just join these 2 points up. If I join these 2 up from here, what I get is a straight line going all the way through there. Okay, so in this line here is 5x plus 2y equals 20. And I didn't have to rearrange that into y equals mx plus c if I was using this type of method to find my points of contact. Okay. So next one I'm going to go for is I'm going to be doing the other equation. So y equals 2x plus 1. So y equals 2x plus 1. So all I'm going to do is I'm going to work on that being my c value, c of 1, that there being my m value or my gradient. So that's my gradient. And remember the gradient of 2 is equal to 2 over 1. And that means every time I go along 1, I go up 2 places. Okay, so that's what I'm going to do on the graph. So I'm going to start from the point 0, 1. So that's what this point here would give us. 0, 1 would be the coordinates. And here we go. So 0, 1 would be there. What I'm then doing from there is I'm going to be going along 1 and up 2. So along 1 and up 2. There we go. Along 1 and up 2. Oh, there's my point of contact, I think. And point of intersection. So I'll just draw through the dotted lines that are here. There we go. And all I need to do is find where they cross over. So in the x direction, okay, x direction it's going to be 2. So the point of intersection where they cross over is going to be 2 along in the x direction. And it's going to be 5 in the y direction. Okay, So all I've got there is my point of intersection is 2, 5. If it asks me what x is equal to, well, I might have to say x is equal to 2, or if it asks me y equals 2, is 5. So I would just write that out separately. If it's asking for the coordinates, it's the coordinates in brackets. Don't forget your brackets when we're doing this type of work here as well. Okay, that's what we're doing with some of the simpler equations when we're just given the equation of the line. Quite often we're given a kind of scenario that we've got. And what we have here, if I can just run through this one quickly with you, we're looking for a point of intersection. Okay, the two tanks are being topped up, so two separate tanks. Tank 1 has 10 litres in it, okay, and it's being filled up at a rate of 3 litres per minute. Tank 2 has 15 litres in it, and it's being filled up at a rate of 2 litres every minute. So that's going to give me my gradient, and the 10 litres and 15 litres my starting point, where I'm going to start from. Okay, so I've also been given the equations in here. It's not in the normal form that we've been given them, so usually we get them in the form of V is equal to, and I'm going to put 3t first because that gives me my gradient that's there, plus 10, and that gives me my C value. The second tank, V is equal to, and it's going to be 2t, and that's plus 15. So that gives me my C value and gives me my gradient. So what I'm going to do is I'm just going to draw these out reasonably quickly so you can see what we're going to do from there. It's asking me after how many minutes will the two tanks hold the same amount. So that's the point of intersection that I'm really after. Okay, so I've got volume up on this side here, and what I've got here is time in minutes. Okay, so the first equation was V is equal to 3t plus 10. Okay, so I'm going to start at 10, starting at 10. And what I'm going to do is, every time I move along 1, I'm going to move up 3. Okay, so 1 along, 3 up, there, that's there. 1 along, 3 up, that takes me to there. 1 along, 3 up would take me to there. And what I'll do is I'll just draw a straight line through all of these points that are here. So it should take me about there. Okay, so this line here is V is equal to 3t plus 10. So my next equation that I'm going to be drawing is V is equal to 2t plus 15. So what I'm going to do is I'm going to start at 15 and I'm going to go along 1 and up 2 based on that gradient. So I'm starting at 15, so there's 15 there. I'm going to, every time I go along 1, I go up 2. Along 1 and up 2. Along 1 and up 2. Okay, and what I'll do is I'll just draw through these lines as well. So if I draw through these lines, what I should get is a line that looks like that there. So this line here is V is equal to 2t plus 15. Now the green line is tank 2. Okay, so that one there is tank 2. And the purple line is tank 1. Tank 1. Okay, so what I'm looking for is the point of intersection. And what we're asking for is what point do we get where the tanks hold the same amount? So it's that point there, and only that point that's there. So that point there, if I look at the coordinates of that, so the point of intersection is going to be 5, 25, okay? So 5 minutes along, 25 litres both tanks will hold. The question that I was asked though, if I go back to my question, was after how many minutes will the two tanks hold the same amount? So what it will be is after 5 minutes. So after 5 minutes, both tanks hold the same amount of liquid. And that is going to be, the liquid that they're going to hold is 25 litres. Okay, so that's what this topic is about, finding the point of intersection where two lines cross over. Sometimes we may have a scenario that we need to work out. Sometimes we may need to make a decision based on what we're doing with the taxi driving. If you think about that one that we had at the start, or the hire a car company. Sometimes it's just a straight line that we need to work out between two straight lines where they cross over and what is that point of intersection. Okay, hopefully you've learned how to do this graphically. What we'll be doing is we'll be doing some work today based on this topic. Beyond this, we're going to be working out simultaneous equations algebraically without drawing the graph. Okay, good luck for this today.